Alright, this is 4.2 and 4.6 in Advanced Geometry. Today we learned the triangle sum theorem. All it basically says is that all three angles of a triangle add up to be 180 degrees. So we're going to keep it nice and simple. Like what you need is a triangle. You need two angle measures provided. You can find the third angle. So since all these bad boys add up to equal 180 degrees, we're just going to use our calculator and take 180 minus 62 minus 90. So we'll take 180 minus 62 minus 90 and get 28 degrees. So we're going to put it two places. We're going to put it in the picture, and then we're going to come down here and say measure of angle 1 equals 28 degrees. All three angles should add up to be 180. So in our next one, they need to give us two angle measures provided. They give me this being 30 degrees, but they have arc marks here, the same amount of arc marks. So that means if this guy's 30 degrees, then this guy's 30 degrees. And then you can punch in 180, take away 30 again, and you can figure out the measure of angle 1. I'll let you punch that in, and you should get 120 degrees. So the measure of angle 1 equals 120 degrees. Then they get a little more complicated picture. So there's really three triangles in this picture. You've got the red triangle right here. Inside of it, I do not really know two angles provided. And then if we check out this other triangle down here, we do have two angle measures provided in it. This one's 90 degrees, that one's 30 degrees. So we can use the triangle sum theorem. My bad. Where did we go? Hey, get bigger. My bad. So we can use the triangle sum theorem to figure out that if this is 90 and that's 30, that this has got to be 60 degrees. And then, honestly, we can figure out this angle measure right here because we have a linear pair between these two angles. This red one and this blue one form a linear pair. So if this is 90 and they have to add up to be 180, that's got to be 90 degrees. And now in this top triangle right here, we have a 60 degree and a 90 degrees. So that's got to be 30 degrees in there also. Right here, you got two different triangles. You need to find one where you know two angles in it first. So as you can see here in this red triangle, I know that's 66 degrees and that's 58 degrees. So we'll punch in our calculator and take 180 minus 58 minus 66 and get 56 degrees. And we'll put it in the picture. And then our buddy shows up. These are vertical angles, so if that's 56, this has to be 56. And now in the triangle on the right, I have two angle measures, so I can take 180 minus 56 minus 50 and get that that's got to be 74 degrees if I punch that in right, which I did.
Today we're going to find how many degrees possible inside of any particular convex polygon. So let's fill out our chart. Let's start with the smallest amount of sides we could have for a polygon, which is what? How many sides? 3. And let's draw a picture of that with our geometer. Wouldn't that be a triangle, correct? So let's draw a nice, neat triangle. That'll fit in there. Doesn't matter which one. I could care less. Cool. And then the next column is about how many triangles do you see in the picture? How many triangles do you see in the picture? One triangle there. And how many degrees possible? That's something that hopefully you learned in middle school. How many degrees are all three of these angles add up to be in a triangle? 180. If you didn't know that, that's okay. That's called the triangle sum theorem, that all three angles add up to be 180 degrees. Sound all right? And that's the basis of our experiment. So far we know that this triangle has 180 degrees in it. Let's move up a step. What's the next number of sides you need? 4. What's that called? Quadrilateral. So we'll draw any which one you want on there. I could care less. Shape 12 is the one that's supposed to be the square. There's rectangles and other kinds of quadrilaterals. Just got to be a polygon with 4 sides, right? But this next category of how many triangles do you see in the picture, that's all messed up yet because we're not ready for that. What we need to do is pick one of the vertices, any vertice we want to. Aren't there 4 total vertices in this picture? Just pick one and put a big fat dot on it. It matters not which one there is, okay? But our job is to draw all of the diagonals that we can from that one fat dot that we put in there. What's a diagonal again? It's a segment that connects 2 points that are not already connected. So I want to draw them all from here. Wouldn't that be a diagonal? for sure. Are there any other diagonals I could draw in this quadrilateral from that one dot that we picked to start with? No. We know there's another diagonal in there, but it doesn't go from that dot, correct? So it's all about picking one dot. Now look at that picture. How many triangles do you see in the picture? There are 2 triangles. And since they both have 180 degrees apiece, right, which we'll need a calculator today anyway, but 180 degrees here and 180 degrees there, correct? How many total degrees would that be? And you probably knew that already, that all quadrilaterals have 360 degrees if they're convex. That's the trick. The only thing is these shapes have to be convex. They can't dent in, if you will. Alrighty? Next guy, 5 sides. What's that called? Pentagon. Let's draw one. Got to be convex for this to work. Then pick any vertex you want to. Doesn't matter which one. Put a fat dot on it. Draw all the diagonals you can from that one vertex. Hey, is that a diagonal? But it's going horizontal. Is that a diagonal? Yes, because it connects. It's a segment that connects 2 points that are not already connected. Can I draw any more diagonals? Yep, I can go there, right? Can I draw any more diagonals from that one point? Nope. How many triangles do you see in the picture? 3. And they all have 180 degrees in them, right? So if this has 180 degrees, everyone grab a calculator and figure it out if they don't know. This has 180 degrees, and that has 180 degrees. How many total degrees are in any convex pentagon? Nice. Next, 6 sides is up, right? What's that called? Hexagon. Whatever my shape maker is. La da 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 da. Then pick any vertex you want to. Doesn't matter which one. And draw all the diagonals that you can from that one vertex. How many triangles are in the picture when we do that? 4 triangles at 180 degrees apiece. Correct? Total of 720 degrees. And we could keep going and going and going and going, but it's time to look at our experiment and see if we can figure out a pattern. Because couldn't we just keep going to 7 sides, 8 sides, 9 sides, 10 sides, 11 sides, 12 sides, 13 sides, and we go on forever? Let's see if we can find a pattern. Does anybody see one before I go on? We have noticed that this number is 2 less than the number of sides each time. So let's go to our last guy and say n. N number of sides. And we won't have a picture for that, obviously. But if this is n sides, and you told me that this guy over here was always 2 less, what do you want to put right here? N minus 2, and we'll make it a quantity right there. That would be how many triangles there would be in the general case. There's always 2 less, right? If there's n total sides, minus 2 from that, and that's how many triangles there would be. Well, then what did we do to get this number each time? How did we get that number? Add 180 to it? Didn't we take 4 times 180 and get 720? Didn't we take 3 times 180 and get 540? So what do you want to do to figure out how many degrees there are? N minus 2 times 180 is the formula. That's it right there. If you have any convex polygon with n number of sides, you can figure out how many degrees are inside of it by taking the number of sides minus 2 first, then multiply that times 180. So let's move to these sets of problems right here, which you have down a column. I got them over nice and spread out. All I need to know first is how many sides this bad boy has, decagon. So here's my formula, n minus 2 times 180, correct? This has 10 sides. Let's do some mental calculation. What are we going to take times 180? 8 times 180. I don't need to see any work. It's so simple. Let's just take 8 times 180 in our calculator. And what do you get? 1440. There is 1,440 degrees inside of any convex decagon. Make sure you put degrees, though. You with me? 16gon. How many sides does a 16gon have? Pretty sure it's got 16. So what are we taking times 180, though? 2 less. 14 times 180 is 2520. Is that what we're getting? 2,520 degrees. Get the rest of these problems done. So, should have got these as follows once you punched them all in. Number of sides minus 2 times 180. Now, for these problems, you don't have much room on your 7, 8, and 9. Sorry that these are number 4, 5, and 6, but you got 7, 8, 9. Do the work down there at the bottom. It says the measure of an interior angle of a regular polygon is given. Whoa, what's a regular polygon? Equiangular and equilateral. All sides the same, all angles the same, correct? So here's the thing. It's regular. The main thing is we're talking about angles, angles, angles. Isn't this the measure of one of the interior angles in that? Well, let's figure out what the formula would be for, like, if I had a regular polygon. Let's just make something up here. Let's say I had a regular octagon. I want to know what's the measure of one angle of a regular octagon. How would I figure that out? What's the first thing I got to know? Well, 8 sides. Yes, we do need to know that it's got 8 sides, right? After we figure out that there's 8 sides, what do we need to know after that? How many all the angles add up to be, right? And how would we figure that out? With this formula. Wouldn't we do that in the general case? So help me out. Octagon has how many degrees? 1080, right? Degrees. But that's all of them. I want one of them. How many angles are in an octagon? 8. So wouldn't we take this number and just divide it up 8 equal ways since all of them are the same, correct? And what would that be? Punch that in for me. 135? 135? 135 degrees? Okay. So how about a formula for the general case? Isn't this the total degrees, just like that 1080 was, right? We had to figure out the total degrees first. Then what did we have to do? Divide by how many angles there were, right? Well, how many angles are in an n-gon? Shouldn't there be n? So what would we need to do to this formula to make it be one angle of a regular polygon? All over 2? Or n? N. Let's write that off to the side up there by this problem, by the instructions, that this is the formula that we're using. This is the formula for one angle of a regular polygon. This is the formula for one angle of a regular polygon. You all down with that? So let's reread what they gave us after we get this written down. You're going to want this formula written down. I don't remember if it's on your cheat sheet or not. So yes, it is on the cheat sheet in the polygon section. So let's go back. What did they give me here? So what we'll do, since this is one angle of a regular polygon, we will start with that formula. N minus 2. Remember, we're doing our work down below. Times 180 over n. Isn't that what the formula is for one angle of a regular polygon? And isn't this right here one of the angles of a regular polygon? So we'll say it equals 150. We know what one of the angles is. What we don't know is how many sides it has. And isn't that what n stands for? N is the number of sides. So we don't need a security alert. We will just solve this problem instead. Let's get rid of the ugly part. Isn't there a divide by n in this bad boy? So let's get rid of that by multiplying both sides by n. And what would happen is we'd get n minus 2 times 180 would still be there. What would be on the right side if we multiplied both sides by n? 150n. You all cool with what happened there? All I did was get rid of the divide by n by multiplying both sides by n. Cool. Next move. What do you want to do? What's that called? Distribute the 180. Very nice. 180n. And then what's 180 times negative 2? Negative 60. That'll equal 150n. Y'all with me? Next move. What would we do since we want to solve for n? What's our next move? Subtract 180n. So wouldn't a negative 360 come down when we do that? 150n, take away 180n. How much n? Negative 30n. And it's starting to look nasty. We got all these negatives. Negative, negative. Should n come out to be negative? No. Absolutely not. But it's good that we have all these negatives, because when we divide both sides by a negative 30, what's a negative divided by a negative turn out to be? So I don't need to type in negative 360 divided by negative 30. Don't you just want to type in 360 divided by 30? What's 360 divided by 30? And that came out nice. That means that this was a 12-sided polygon. It said find the number of sides in this regular polygon when each angle measures 150 degrees. Well, that means that that polygon had 12 sides. Let's do it again here with this next problem. Same idea. Let's take that formula for the number of angle, the measure of one angle of a regular polygon, and set it equal to this. Because that is one angle of a regular polygon. And on your homework, there'll be much more room for you to work on these problems. I just tried to squeeze it all in on this worksheet. So what's the first move? Multiply both sides by n. Feeling good with that? Then what's the next move after that? Distribute. So that'd be 180n minus 360 again. And that would equal 160n. Correct. Then we got to subtract 180n over, right? So we'll be left with negative 360. What's 160n take away 180n? Negative 20n. And again, we'll have a negative divided by negative, so that'll come out positive. 360 divided by 20. 18. Awesome. Now, let's see if we can do it faster, meaning do more than one step at one time. See if we can handle that. We will write the formula down again for this next guy. N minus 2 times 180 over n. This time it'll equal 175. I want us to start that way each time. Cool? Let's see if we can do two things at once now. What's our first move? Multiply by n. Now watch this. Wouldn't you all agree that this would come out to be 175n? Right? Equal sign's still there. You'd be left with this. Isn't the next move after that to distribute that through? So let's see if we can do that right away also. Wouldn't that just be straight up 180n minus 360? You see how I did two things at once there. If you can't handle that, don't do it. But I distributed that 180 through, and I multiplied both sides by n all at the same time. Solve for n. 71, 72. That's a lot of sides.
So here on these problems, they want us to find the value of x in the polygon below. As you can see, it's a convex polygon, and they list basically all the interior angles. What I need to know is how many degrees possible inside of this convex polygon. So, being as how this is a quadrilateral because it has four sides, we could use our formula or our chart and realize that there are 360 degrees possible when you add up all the interior angles of a convex quadrilateral. So I like to write that on the inside, me personally, and I just need to add this up, 2x plus 5 plus x plus 2x plus 7 plus x. Well, we're smart enough to add up all our like terms right away, because 2x plus another x, plus another 2x, plus another x. They're all like terms. So here's 4x, 5x, 6x, plus all these constants. 5 plus 7 is 12. They need to add up to be 360 degrees. That's what happens when I took all four of these bad boys. They should all add up to equal this. So now we can simply solve for x. 6x should equal 360 minus 12. So if you need to punch that in, you can. But 360 minus 12 is a nice 348. And then we can divide that by 6. And boom, x equals 58. It doesn't equal 58 degrees, it just equals 58. Now if we sub back in and find the measure of all the angles, like the measure of angle R is 58 degrees, measure of angle T is 58 degrees, and etc. So if we do that again, the big difference here is this is not a quadrilateral anymore, it is a hexagon because it has 6 sides. So number of sides minus 2 times 180 would give you 720 degrees possible on this. So we need to add up all these angles. So there's 1, 2, 3, 4, 5, 6 x's, because again they were all x to the first. And then adding up all my constants, I just grab ye old calculator and I'm going to clear that out. And I got 2 minus 8. I'm going to start here and go round the clock. So 2 minus 8 already got punched in, plus 7 minus 3 plus 6 minus 4. All those constants, well, isn't that just something? They add up to be nothing. Double check that. 2 minus 8 plus 7 minus 3 plus 6 minus 4. So 6x equals 720, and divide 720 divided by 6. And that means that x is 120 degrees. So 120, no, sorry, just 120, not degrees. So x is 120. So let's try that again.
Number of sides minus 2 times 180, and get how much? Here's the secret. You get 540, put it right here. Whatever they're supposed to add up to, I like to write that right there, because we'll get in a bad habit later of thinking everything should add up to 360, everything should add up to 360, everything should add up to 360. No way, this is a pentagon. Everything should add up to be 540. You with me on that? Then shouldn't we take this plus this plus this plus this plus this instead of equal to 540? That would be ugly looking if we wrote it all out as 4x plus 5 plus 5x minus 5 plus 6x plus 10 plus 4x minus plus 10 plus 7x. Wouldn't we have to combine all the like terms right after that? So let's do that with our x's. Let's see if we can do some cool stuff. Check out these guys. I like to kind of underline where I've been. There's a 6x and a 4x, which is a total of how many x's? There's 10 x's right there, and there's 5 more at 15, 19. How many total x's? 26x, right? Now I need all my constants. You know what I mean? Without the stuff without variables. So here's a plus 5 and a minus 5. How much is that? 0, 10, and another 10. 20. Now I want to ask you something. Are there any angle measures that are like straight up provided? I see this happen all the time. Let's just pretend for a second that that wasn't there and it said like 100 degrees. Would that need to get added in there? Is it one of the angle measures? Aren't we adding up all the angle measures? So don't leave anybody out. You know what I mean? But it's not 100 degrees. Don't leave anybody out. If things come out really, 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 really weird, double check that you have added all of the angle measures together.
So where would you put the 100 degrees?
Well, it would go in with the constants. Where would you put the 100 degrees was the question. It goes in with the constants, not the variable stuff, right? You're just adding up constants, okay? So I got this, right? I see a lot of people try to solve this. You go, how can you solve that? That's an expression. I need an equation. What's my equation? Equals how much? They should all add up to equal 540. Sound good? Solve for x. This should be something that you could do mentally, right? So 4 times 20 is 80. Add 5 to it. What do you get? So measure of angle D equals 85 degrees. Can I call that angle D? Or do I got to call it by 3 letters? How many angles have D for a vertex in this picture? What do you think? Pretty sure it's just this one, right? Are there any other angles with D for a vertex? Nope. So measure of angle D equals 85 degrees. Put 20 in here. What's 5 times 20? That's 100. Take away 5. What's the measure of angle C? 95 degrees. Measure of angle B. That'd be 20 times 6, which is 120. Add 10 to it. How much you get? 130. Measure of angle A. 80 plus 10 is 90 degrees. Measure of angle E. How much? 140 degrees. How many angles should I have? What do they all add up to be? A smart student would add those up and see if they all add up to be 540. It would let you know that you did all your math right. Got a calculator, it'll do all the work for you. This is so easy that it's extremely easy. People scratch their head and go, is that it? Exterior angle theorem. The sum of an exterior angle in a convex polygon at each vertex is 360 degrees. So check it out. See this bad boy right here? This is the polygon, this green thing. But you see all of the overhang, that kind of, I know it's not a polygon if there's overhang, but it's just a picture now. This green thing's the polygon, this overhang's part of it, but this is an exterior angle to it right here, that angle out there. There's an angle on the inside. If you extend out the sides, that's talking about an exterior angle right there. Sound cool? It says if you add them all up, in any polygon, you add all these guys up, they'll always add up to 360. Just a fact, Jack. All exterior angles in a polygon add up to be 360. So check this question out. Find the sum of the measures of the exterior angles of each convex polygon. That is, of course, if they're convex polygons in the first place. So convex decagon, what will all the exterior angles add up to be? 360. Convex 16gon, what will all the exterior angles add up to be? 360. Convex 36gon, what will all the exterior angles add up to be? 360. Just that easy. It's just a fact, Jack. All of the exterior angles in any convex polygon will always add up to be 360 degrees. Now, this says find the measure of each exterior angle of a regular hexagon. That's not just any old hexagon. What's so special about it? It's regular, correct? So, do they want an interior angle or an exterior angle? Exterior angle, just one of them. Do you know anything about the exterior angles of a hexagon? All add up to 360, right? So I know I could take boom, 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 boom. Those, add them all up, they're 360. But this is regular. So what do you know is really fancy about regular polygons? Aren't all of these supposed to be the same in here? Correct? Well, what does that mean about all those exterior angles then? They all got to be the same because aren't these linear pairs just left, right, up, down, all the way around, right? They're all the same. So aren't all of these the same? How much do they all add up to be? 360. They're all the same. How many of them are there? There's 6 of them. They're all the same. They add up to be 360. There's 6 of them, and they're all the same. How do you figure out what they measure? 360 total, split up 6 equal ways. I need to see that. That's all I want to see. 360 over 6. Then you can tell me what that is. No calculator. Who in the world knows what 36 divided by 6 is? It's 6. But wasn't there an extra 0 involved with that? So 60 degrees is the measure of each one of those exterior angles. Cool? Next. Rectangle. Definition. What do you think it is? I talked about it last time. Do you remember? What's a rectangle? First of all, what kind of polygon is it? It's a quadrilateral. What's so special about it? It's got 4 right angles. It is a quadrilateral with 4 right angles. That is the definition of a rectangle. It is a quadrilateral with 4 right angles. Anytime I ever ask you to draw a rectangle, you better draw a quadrilateral with 4 right angles. So let's do that on number 5 right below it. Draw me a rectangle. Take a wild guess which shape on the geometer is really the rectangle. It is number 7. So if we draw number 7, so if I draw, I gotta do this, is that good enough? Nope, that's just a quadrilateral. What do I need in it? 4 right angles. So draw that. What if I drew this? Shape 12. Is that a rectangle? Yes, it is. Is it a quadrilateral? Yes. Does it have 4 right angles? Yes. That's a rectangle. What if I put tick marks on all 4 sides? Then is it a rectangle? It's something more than a rectangle. It's still a rectangle. It doesn't lose the properties of being a rectangle, but they didn't say draw all those tick marks or anything like that. Okay? You only mark it by its definition. Some of you will end up doing this. That is wrong when you are asked to draw a rectangle, because those are properties of rectangles, that opposite sides are equal. We don't draw stuff by their properties, we draw stuff by their definition. So when they ask to draw a rectangle, you draw that. What's a square then, by definition? Can you figure it out? What shape is it, first of all? Quadrilateral? What's it got? 4 right angles and 4 equal sides. Quadrilateral with 4 right angles and 4 equal sides. I guess I forgot to put the GHJK in my previous picture. Make sure you had the GHJK in your picture. Because they said draw rectangle GHJK. So a square is a quadrilateral with 4 right angles and 4 equal sides. Then draw square element O. Element O. So there's our square element O, 4 right angles and 4 equal sides. Circle definition. The set of all points in a plane the same distance from a given point.
The set of all points in a plane the same distance from a given point. Here's what that means. Like if I was to draw a circle right here, I have to start with some point. So this is the center of the circle right there. And then if I go any distance, let me grab a segment instead. Get rid of those arrows. So if I go any distance away from that point in a plane, mind you, I'm going 2 dimensions, so I can't go like I can only move in 2 dimensions. If that distance right there was 4, and this distance right here is 4, and this distance was 4, if I did that an infinite number of times, if I just went 4 units away in a plane, I would get this thing to form, this green guy right here. Every single point, if I go 4 units away from the center of that circle, would form that circle right there. So it's the set of all points in that plane the same distance, which that's called the radius, which we should know that already, from a given point. So to name a circle, you name a circle by its center. By its center. To name a circle, you name it by its center. So when they say draw a circle K right here, we could grab our geometer, and down there at the bottom we've got those circles. You can just grab any of those that you want and go ahead and draw the circle. It doesn't have a point for you to put in the center, but you need to draw that point right there. And then if they want us to draw circle K, that's what this symbol is. It's the circle symbol. It's an O with a dot in it. That means that K is the center of that. So we got to put a capital letter there for K because that's a point. So this is circle K. So that's what a circle is. All right, man. Let us know if you guys have any questions. Have a good one.